Hello everyone, it's very nice to see you, so many of you, especially after the lunch. Today I would like to give you some few examples of the daily performance pitfalls, but let me introduce myself. It is my first time in Russia, that I live in Poland, in the city called Wrocław. I can say that I have two positions because I'm co-founder of DotNext. It is an initiative of me, Szymon Kulec and Konrad Kokosa. We do performance things like performance conference in Warsaw or the meetups for the local communities. I also work remotely for a Swiss company called Sonova, and you can find me on Twitter just by typing Łukasz Pyrzyk. So the agenda for today is quite long, but we will try to make fast. We will start with assuming performance improvements by looking at the code, which may look faster, but under the hood maybe not. We will try to decompile the code with the simplest option ever by using a website called shardlab.io, and I will show you how compiler may predict your ideas. I will tell you a very funny or not story about releasing product in debug mode. We will take a look on few assumptions on debugging, on relying on the debug code that behaves sometimes differently. We will try to stream data through ASP.NET Core. We will see the tired compilation in action and his negative sides. I will also show you how to optimize your code with array pool and how you should do it correctly. Also, I will mention Cosmos DB and very simple optimization that you can do by reading the official documentation and few articles from the Cosmos DB team. And we will finish with the quick example of how business can ruin our performance by making the requirements. So some time ago, I was scrolling down the Facebook, and I found out a funny group called I'm Programmer, I Have No Life. And this is a meme that shows the difference between the young programmer and the experienced programmer. I said, okay, maybe it's fine or not, so I will look deeper for another memes, and I found out this one. It shows a rapper from US called Drake. Drake says that swapping two variables with third variable for temp variable is not cool. Drake says that we should use free XOR operation because it's much cooler. It's maybe even more readable sometimes. So I thought maybe, okay, let's make some assumptions. Let's make assumption that it is faster. Why? In theory, I can say that, for example, this method doesn't use third variable. Third variable was int, so maybe allocation of int on the stack or just typing in it may take some time. It may take 4 bytes because that's the size of the int. Also, the XOR is probably implemented on the CPU level, so the processor has special instructions. So when we are typing XOR, maybe it will be executed on the better performance than typical swap. I did output from benchmark.net that shows EL and assembly code. As you can see, or not from the last rows, we have few XOR operations and few move operation. When we switch to the temp variable, we have only 4 moves. Let's just delete the EL code because it's not relevant right now, and let's focus on assembly. That's the assembly code for the XOR temp algorithm. As you can see, it has move operation, then XOR, then move, then XOR, then move, then XOR. 3 moves, 3 XORs, and then it returns. Comparing to the temp variable, it is smaller. Temp uses only 4 moves and doesn't use anything else. So, do you have any assumption which will be faster or not? No, let's measure. So, on my computer, the XOR took near 3 nanoseconds. However, the temp variable took 0.000 nanoseconds. It is a tricky, but if you have one of the latest versions of benchmark.net, you may notice the error saying that the method duration was indistinguishable from the duration of the empty method. So it was as fast pretty much as the empty method in .NET. And we couldn't measure how fast it was. There is also a third method for swapping variables, just for you. It's about adding and subtracting values in correct order. And at least on my computer, it was the slowest one, but the difference with XOR was pretty much not relevant. I tried to find out if it's the typical JIT behavior, or maybe it behaves differently on different JITs and different platforms. So for example, I did a benchmark that runs on the CLR, it runs on .NET Core, and on Mono. And as you can see on the red, the Mono temp variable, the temp swap variable, is also the fastest option, but it's slower because it uses additional assembly operations. And as you can see, Sometimes something is faster on the .NET Core, but it might not be on the Mono, even if assembly shows that. With such knowledge, you may say, okay, it's very simple, I will try to do it at home, because after the conference, the second day of the conference, you will start Visual Studio or Sharp.io, and you will start typing. So imagine a method that looks like this. You have two ints, 1K and 2K in hexadecimal. You swap them with XORs, and you want to print the output to the console, just to find out if it works. Later on, you create a second method called, for example, temp variable. You use the temp variable, and you want to benchmark it somehow easily. And when you do it, you might be surprised, but it will be the same. Why? Let's use sharp.io. It is a website that allows you to copy-paste or type C# and see output in assembly code or in intermediate language. Code on the left is a typical XOR, and code on the right is output in assembly in debug mode. As you know, comparing code in debug mode doesn't make sense, so let's switch to release. With release, we have only 8 lines of assembly. So you may say, okay, it's only 8 lines, but you need to be careful and read those lines. Because in such example, a compiler was smart enough to determine that your swapping was equivalent to printing the same values in different order. So even if you could use the third algorithm that adds a subtract with this form of the method, compiler will be smart enough just to print them in different order. So you need to be very careful, and if you are doing some micro optimization, it is very useful to take a look on the assembly output. If you are talking about debug and release mode, let's jump into the story about releasing product in debug mode. Have you ever done this? Yes, at least 2%. Because usually people say not gonna happen. Everybody knows. So I will tell you a story. Do you like YAML? Exactly. So I will tell you a story about YAML.net. They had a benchmarks based on speed on the stopwatch and loops. So this is the part of their code in the past that was running a benchmarking. They had a collection of tests. They create a loop. Inside the loop, they started a warm-up of the test, and later on, they were doing n iterations of the test and making a pretty much average of the time execution. As you know, it's, let's say, very, very, very old times of kind of benchmark. So we had a guy in Poland called Wojciech. He's from Gdańsk, and he wanted to say, OK, I want to contribute to open source, so I will rewrite it with benchmark.net. He did very simple code that prepared pretty much the same setup as in the previous examples. He created the needed object for YAML.net, and he created a very simple method called serialize that just calls serializer. Later on, he moved to the console and just typed .NET run configuration release. And he was very surprised that he received a warning saying that assembly YAML.net, which defines benchmark reference, is not optimized YAML.net. What does it mean? It means that some of your dependency that you are calling is in debug mode. So what's the problem? After some time, he found out that they are released configuration in Visual Studio, but they are quite old. However, YAML.net ported from old CS project to new CS project. And there is a quite important difference. Because right now, when you have new CS Pro, the configuration for release wildcard doesn't inherit from release automatically. So when the guy just moved to the new CS Pro, they forget about turning on the optimization. And the fix was very simple. He just added new condition to the CS Pro saying that if the configuration name is release signed or release unsigned, just enable a constant release and turn on optimization. To give you an example, the version on the Nugget called version 4, which was already optimized and shipped. Let's say that's our baseline. The version 4, which was the version released in debug mode with new CS Pro and Centra, was 2 times slower, but it allocated 2 times less memory. As you can see, there were some optimization done during this development on the version of 5, but it was finally released in debug mode, so the performance was even slower. When Wojtek changed it to the release and optimize, he discovered that it is pretty much 4 times faster, and he just edited 2 lines of the code. If you want to read the full story, it's available on his blog site. I very encourage you to do it. Let's move to another kind of issue or task that you may spot in your company, and it's about buffering or streaming responses. Let's imagine that you are owner of Microsoft.com, the server or the domain, and your task is to make somehow the link for downloading the latest .NET Core, for example, version 3 or version 2 in preview in this case. You want to have a consistent place where you put binaries. Let's say that is our GitHub. GitHub puts binaries in the /archive /version number .zip or .exe. If you have a client, you don't want to send them a link like this, right? You don't want to expect from, for example, Microsoft or your company that you will have to click for such long lines. So I would like to have a link which looks like .net.microsoft.com/download. That's it. How to do it without moving the file or caching it somewhere? You may start with creating playing with HTTP client and creating HTTP request message. It is then, let's say, our base request that you can use with HTTP client. You may say that I want to get method from GitHub. When I have this request, I'm calling client.sendAsync. It knows that it's get request because I specified in the request message. Later on, when I have the response, so I can check if it was successful or not, and I can grab a stream from this response by calling read_as_stream_async. With the stream, I can check the content type and return to the user file stream result. So I'm passing the stream, so it should be buffered, right? Streams should be buffered. Unfortunately, when you ship this kind of code and you call it a few times, you may notice that your memory usage grows significantly fast, and you may even crash the server if the file is really very big. We also notice that the download doesn't start automatically. It starts after a while. Why? Because under the hood, read_as_stream_async downloads the whole stream into the memory, exactly to the memory stream. That's the type of the stream. And later on, it passes the bytes with memory stream to the user. So instead of buffering the file from one server to the client, you're just downloading the file to your server, allocating it to your memory, and later on you are putting this data to the client. It's bad, and we should fix it. There is a very important enum in HTTP client world. It's called HTTP completion option. It has two options, and one of this is response headers read. When you use the overloaded method of send_async and you specify response headers read, it will ask HTTP client to send the request, wait for the response, but don't get the stream from the response. You would like to check only the headers from the response because you would like to, for example, check if what's the status code, if the request was completed successfully. But you don't want to touch the stream. Let's wait for the stream and redirect it later. When you put this very simple enum, the code will behave very, very cool. You will reduce your allocations. It will improve performance and stability of the code because right now you will streaming file through the servers. You can do this trick for a lot of streaming data. For example, if you are doing very, let's say, high performance JSON serialization, and you are getting data from the server, you can grab a body from the server, and you can pass this not yet downloaded stream to the JSON serializer, so that it will be serialized during the downloading. There is also another method on the HTTP client called getStreamAsync, and it does pretty much the same as I showed in the previous example, but right now we don't have the access to the previous features like response code, etc. Usually you may spot the people use the getStreamAsync, and that's all. But this method is pretty much equivalent to the overloaded option. Let's jump into the next case. And this case is about relying on the object state. Let's imagine a very simple main method, which has a timer. We are using the timer from sister.threading the timers. And we are saying that after each 100 milliseconds, we would like to print the current date time in etc. Later on, you're just typing something to the console just to make sure which code executed in which order. So right now, I'm just asking the user if the execution has started. Later on, I'm calling gccollect. And then I'm waiting for input from the user. Do you know what would be the output of the execution in debug? OK, so let's check it. If you run it in debug, you may notice that the timer has started. You will notice that it sometimes competes with console write line when it comes to order, but it prints the current datetime after each 100 seconds until you type something on the keyboard. Cool. Unfortunately, when you ship it to in release mode, you may discover something else. Because right now, it will also compete with the order, but the timer will stop. This kind of, let's say, optimization or trick used by JIT is called eager root collection, and it is completely valid case for jitter. The JIT did correct job. And eager root collection is an optimization which makes the local references irrelevant after their last usage. JIT is, let's say, smart and able enough to determine which variables are used when, and if the variable is not used, it can be garbage collected, and we call it garbage collect, right? To fix this issue and be consistent on debug and release and another platform and configuration, you may call a very old but useful method called gc keep alive. It is one of the shortest methods in .NET because it does pretty much nothing. It just accepts a reference, so the compiler knows that your local reference is used somewhere else, so it can't be garbage collected before that. If you want to do it even more correctly, you can check that the timer implements iDisposable, so it will be even cleaner for you to just call simple timer.dispose. Of course, you may say that, okay, we have using statement, and with using I can create a scope, and it looks even better, right? But we have C#.8, and I think presentation about C#.8 is in the room next to us. So let's talk about the features. Let's compete with them. C#8 has a new syntax for using. Right now, you don't have to create a specialized code for the using statement. Compiler will be smart enough to determine when to call dispose. So if you have several dispose scopes inside of each other, now it will be really more readable because you may align them. Also, there is a new interface called iAsyncDisposable, and it allows you finally to call dispose asynchronously. So you don't have to call getAwait or getResult inside dispose method or do some tricks. You are able to create fully guaranteed iAsyncDisposable method. And this method returns value task, so this is the value and the structure instead of task, so it will be a little bit faster. And with value task, you can do syntax like await using var. So you're combining a few words, but in this place, you are saying that you want to use dispose method, which is asynchronous. If you specify await keyword, the dispose async will be called. If you remove the await, the typical old dispose method will be called. But there is more that I need to tell you about this case. Let's go back to our example, the beginning one, that we have only timer, console, gc collect and read. No tricks with dispose, no tricks with keep alive. We would like to run it in release mode. As I showed you before, in the release mode, the timer should stop. But there is a case when you run it in the release mode and the timer won't stop. Do you have an idea why? In the beginning, I also didn't have, because we forgot about something new. With .NET Core 3.0 that I use by default right now, we have tired compilation, and we forgot about it. Tired compilation, just to give you a very short description, is a new feature in .NET, but it was, for example, in Java for a very long time ago. It enables your jitter to start application faster by creating less optimized code, and later on, if the method is used heavily, it will be recompiled to the more optimized version. It was optional in .NET 2.1. You could enable it by changing the CS project, but it's by default turned on .NET Core 3.0. So if you want to turn it on for the later previous long-time support version, you just need to enable tired compilation in CS Pro. If not, it's by default in 3.0. It sounds fun, right? But you need to be careful with it. Tired compilation may change examples from books. It may change examples from blog posts, from video posts, especially when it comes to comparing assembly, comparing performance. And it is quite typical to use advanced frameworks, for example, benchmark.net to warm up method before, and then you are sure that that method was rejected again, or you can just turn it off if you want for the session or for the specific use case. So if you want to check, for example from the Andrzej Konrad Kokosa book, just if you don't see the same results, check the tired compilation and be careful with your manual benchmarking because you may spot the same issue. Also, there is a trick. Right now, you are able to, let's say, ask jitter to produce the tier 1 version, so the optimized version of the method, by specifying an attribute called method implementation aggressive optimization. It will skip the tier 0 and it will generate a tier 1, so the optimized version. However, it is not guaranteed by Microsoft that this behavior won't change. Because right now we have only tier 0 and tier 1, but there are some rumors about introducing next level of tiers, so like tier 2, tier 3, etc. And right now Microsoft says that this attribute generates the most optimal version, but it may change in the future that it will produce optimal enough version, which is not maximally optimized, because maybe some optimizations are extremely too slow. If you want to check the output of the difference between, for example, tired compilation and not, by checking the assembly, you have two options. I like add-on to the Visual Studio created by Egor called Disasmo. It's add-on to the 2019 Visual Studio. When you install it and configure, the configuration might be tricky or not. You have two options. You need to clone core CLR and build it in debug in release locally, then specify a path, or just turn on, let's say, not still tested output from benchmark.net. When you install it and restart Visual Studio or not, you may notice that right now you have additional option and suggestion from the add-on that allows you to disassemble the method. So from this place, you can ask the Disasmo to disassemble any method in your IDE. And this is the output of the method that starts timer and calls the console write line. That's the output of the tier 0. As you can see, there is a lot of code, 212 bytes. And there is a very small checkbox on the top of the add-on called tired digit. And if you select it, it will put the previously mentioned attribute on the method that you want to measure, and it will ask JIT to produce the tier 0 version, tier 1 version. So as you can see, the code is much smaller, and right now it behaves correctly because it's optimized. As you can see, the total code size is even smaller by around 100 bytes. Let's jump into another issue, or the pitfall. It's about using ETW events. Imagine a very simple application that needs to allocate a lot of bytes. For example, I created an application that goes several times into the same directory. It gets info about the file, and it loads the whole file. This application can do magic with this file loaded into memory. It can change the resolution. It can adjust the colors, anything. I did it in the most primitive way. So I allocated a buffer, 8K, for reading the current buffer. Later on, I allocated a buffer for which is equal to the size of the file. I'm calling openRead or reading somehow the data to the array, and then later on I can do magic with this array. When you start this application with big and huge images in the folder, you may notice that your application has a lot of GC under the hood. And the total memory utilization grows and goes down, and it looks sometimes like a tree. This is the screenshot from running in Visual Studio after 8 seconds. So as you can see, there were a lot of garbage collection in 8 seconds. Let's check results from the output from Purview, because it's very helpful. After 12 seconds of running, the method allocated more than 1 gigabyte of memory. So it's quite a huge allocation rate. What can we do with it? I'm pretty sure that some of you heard this news about new types in .NET, like span of T, memory of T, and also array pool. Array pool is a pretty helpful class, and according to the definition, it provides a resource pool that enables reusing instance of type T. So the T might be byte, so we may reusing the array of bytes. I will change the code a little bit. Right now, I'm not allocating a 8K array for the buffer. I'm renting it from array pool. I decided to use array pool.shared because that's the shared array pool. It's thread safe between the many threads. And it's usually better to share array pool because different part of your application may reuse the buffers. In the second place where I was allocating array for the whole image, I'm again renting an array for the specific file. But you need to be careful with array pools because it can give you a bigger array than you ask. If it has an array of 10 bytes and you ask for 8, it will give you a pretty much adjusted array, because there is no sense to allocate array of each size just to fulfill the user needs. And in finally blocks, I make sure that the bytes are returned to the pool. It's the typical use case of array pool from the many samples in the internet. And when you do it, do you expect huge optimization? What is it? It will be much faster? Who thinks that? Okay, most of you. I had sad news, because it won't be really very faster. As you can see, we still have a lot of GC. Our memory footprint is still growing and going down like a tree. Let's get the preview stats to make some comparison. For example, our total allocation is still around 1 gigabyte, but it's 200 megabytes less. So we saved 200 megabytes, but it's still allocated pretty much 1 gigabyte of memory in 12 seconds. You may wonder why. I used array pool according to the samples. Everybody saw array pool on the presentations. But you may read carefully the remarks about. It says that it can improve performance. It doesn't say that it will always improve performance comparing to the allocation. If you want to understand what may happen, you may use ETW events in .NET. Array pool is fulfilled with few notifications that are sent to ETW, and you are able to read them. This is the screenshot from Purview. If you start Purview, specify which project you need to run, where to store results. You can extend the advanced option, and here you have few fields to check or not. But you can leave everything by default, and just specify additional providers for ETW events. And here you need to specify that you would like to also listen for system.buffer.arrayPool event source. When you do it, after running your application for some time or even a few seconds, you are able to read events from array pool, this specific array pool or all array pools inside your application. I know that it might be not readable for you, so I made a zoom. This is the typical toString of the row. We have an event coming from processor number something, the number 1, number 3. We have information about buffer ID. We have information about the buffer size, the pool ID, and the bucket ID. That's the internals of pool, because you can tune the pool manually. But the most important information for us, it says over maximum size. When you jump into, it means pretty much that you rented too big arrays for array pool, because array pool has some limit. So if you want to overcome this, you may use array pool.create. It creates your own array pool instead of reusing the shared one. And when you call array pool of byte.create, you need to specify max array length. So for example, in my case, I just checked what's the biggest file in this directory, and I said that's the maximum size. You could use some golden number or some optimized version for you. Also, you need to specify how many arrays per bucket, buckets, internal stuff for array pool. In my case, I just said 1 is enough. The rest of the code is pretty much the same. The renting, the returning the code, the arrays. I just change what's the array pool, not shared, to the custom one. And now the application runs very, very, let's say, better. It allocates less memory. It doesn't have GC, at least not from the start, except this one on the peak. And as you can see, what is also worthwhile to note is that the total memory footprint is pretty much stable. We don't have this tree of allocation and then the allocation of the memory. The most important part is statistics and the numbers. So let's go to the Purview results. And as you can see, by reading ETW events, I went down from 1 gigabyte of memory to 60 megabytes of for the whole application. I just had to warm up the pool, and that's it. You can tune the array pool even more because it gives you more information. For example, it can notify you when the pool is exhausted, so you may pre-allocate more buckets, more arrays inside the bucket. And you can monitor which array pool is exhausted or not, which has events over maximum size. So if you want to optimize, for example, your business application that uses array pool tomorrow, or on Monday, or on Tuesday, for example, just change ETW Purview to listen to the events and see in which places you have over maximum size event. And you can change these places to use your custom array pool.create, and you may optimize your performance a lot, at least in the example that I showed you. To summarize, we went from 1 gigabyte and 200 megabytes to 60 megabytes by using array pool and just reading the ETW events, which were helpful. And we reduced the max.gc heap size a lot. The golden number for you is quite big. It's 2 to the 20th power. And if you are renting elements or array bigger than that, the array pool will always create an array and then delete it later. The array won't be returned to the pool. It just be garbage collected later on. Let's move to another issue, another story. I will tell you about relying on library and cross-platform features. Imagine that you are a developer in the Windows team, and you are shipping Windows 10 to the users, and you enable the diagnostics information by default, as it is in Windows 10. And you want to create some API, some entry point for the records. So let's imagine that we need to create some telemetry entry that has a timestamp, it has a user ID, and we would like to store this record somewhere. And we want to be we want to be as fast to make sure that all users of the Windows around the world will save the telemetry for us here without any lag. Let's create a very simple telemetry controller with the ASP.NET Core. It has this default route. We are enabling the API controller, and we are creating a method called insert, and that gets entry from, for example, from the body, or it gets from the current user that sends the request. We are inserting this entry to the database. We can say that, okay, our database is a storage system that comes from services registered to the ASP.NET Core, and we are returning no content. I think the perfect storage for this kind of information would be a blob in Azure, or for example, Cosmos DB that gives you a high-performance blob storage. We will save them as typical entries in SQL API. So imagine the version of the data storage which is slow. Let's call it slow data storage. It is a use case from my life. To initialize the storage, we need to have some options. So we are reading options from the configuration, and later on we are saying that we want to create a document client. This document client connects to this endpoint with this API key. Later on, we need to check somehow if database exists or not. In this place, you can create database in the runtime, like by calling create database if not exist. At least in my policy, we prefer to raise an exception because we want to create database manually with some provision. Unfortunately, it's asynchronous method, so we need to somehow call asynchronous method inside a constructor. You could achieve it differently, for example, by not calling here and call openAsync, which will code those methods. But we want to call it from constructor or somehow automatically. So let's leave it right here. Later on, when we have database, we need to do pretty much the same for the collection. Collection is the old name for container in Cosmos DB right now. So if collection doesn't exist, we would like to raise exception. It's also asynchronous call, so I will also calling getaway to getAsync. Later on, we create a method called insert that creates a URI from the collection name and database name. With this URI to the collection, we are able to save new entry by calling create document async. To fulfill our need, we need to do one last step, which is registering our options and registering our data storage service. I specified registration because it should be the default option when you are not sure about, for example, the race condition inside the client, or you are just not using the instance which is safe between the threads. I tried to stress this local endpoint with data on my local machine, and unfortunately, I was connecting to Azure in West Europe, and I achieved only 1,13 requests per second, which is a little bit more than 1 request per second, right? It's quite slow when it comes to Cosmos DB. You may be sure that it also depends on your routing, it depends on your internet, firewalls, etc. But let's imagine that we are doing this only on my machine. As you can see, it's quite slow and quite ugly, right? This calls to the getaway to get result in the constructor. So let's try to refactor it with following the principles from the documentation and articles. We may introduce a very popular type in many libraries called async lazy. It's a wrapper around lazy of t that enables you to specify asynchronous factory. With async lazy, you can say that right now, you can, instead of client, you would like to store to the field client factory. And this client factory is async lazy of the document client. And in the factory, specify asynchronous lambda. And in this place, you can call async code safety. So we are creating a new document client as before, and you are calling some method called initial database that checks database, it checks collection, it checks, for example, stored procedures or the schema. Also, in this place, you can create a URI to the collection because it is based from the database name and the collection name. In this place, you know both, so there is no sense of creating it after calling each insert method. With that, you may change your insert method to don't create URI after each request. Right now, you would like to call create factory.value, and this asynchronous async factory, so you need to await it. When your first request will come, the database will be prepared, but after next request will be already served on the already created database. So only the first request will hurt you. You can always improve performance. For example, document client has a method called openAsync, but you need to somehow call this method. In our example, it was not possible because the whole storage was created by reflection. Also, the most important change in this code is changing the duration registration to the singleton, because in the documentation of Cosmos DB client, there is a huge information saying that document client is thread safe, and it is really, really recommended for you to have only one document client to each database in your application, because it pulls and caches a lot of things under the hood, like connection and execution plans, and you may achieve a much bigger performance when you just use singleton. With such few changes, I was able to get pretty much 11 requests per second by maybe changing 7-8 lines of code. So it is a massive improvement. Let's do one more very simple trick. Instead of creating very simple document client, I'm using the overloaded constructor, and it accepts connection policy. It is, let's say, pretty much the option for document client when you can specify few settings. And it has options like connection mode and connection protocol. By default, Cosmos DB uses HTTP protocol and a gateway. And when they are developing Cosmos DB, they thought that it may be easier for a lot of systems to communicate over HTTP, because you won't spot any firewalls issues, and it is very, very easy to create, for example, REST API for it. But it's not recommended in the high performance or even performance matter application, because it's much slower. By simply changing the connection policy from default gateway to direct, I also changed the protocol to TCP, and I was able to get more than 2 requests per second more. So I have more than 13 requests per second, and 2 requests for free by adding simple connection policy. Unfortunately, I have a story, and it is a sad story, because we did very similar refactor. We had an application that was based on the microservices calling each other, and one of the microservices used Cosmos DB, and we measured that this is our bottleneck, the connection to Cosmos DB. So we read some articles, we jump in. We migrate to the direct TCP connection mode and protocol, because that was recommended in the official nodes. We added a feature toggle that we are able to enable it in the runtime or during the application start. And after releasing to dev and test, we noticed that we have a lot of gone exceptions, tons of them, like thousands per hour. And the exception was saying nothing else but the request resource is no longer available on the server. What does it mean for you? The first, we have a bug. But then you need to find out what kind of bug and what can raise this kind of exception. My guesses were, I had a few guesses. First one is race condition. Maybe this project has some connection, like in one place I'm calling get entry, and the second piece of code I'm calling the rec entry, and there is some kind of race condition inside the client because I registered in the singleton, and it says that I was getting entry, but it was already deleted because the message says the request resource is no longer available. Or maybe it is a dispose. because you may achieve very similar error when you are calling something asynchronously and later on disposing it in the middle. Or maybe the network is down somewhere. It was a piece of code from the corporation. As you know, corporations have few levels of firewalls, bigger or smaller. Also, Azure has some kind of firewalls, and we moved to the TCP and the direct connection, so we are no longer calling gateway, and we are using TCP, so specific port needs to be open. Maybe something is filtering the packets, and it crashes the packets, and that's the exception. I work from home, and as you know, sometimes it's bad to get your job to home, especially when you want to sleep. And I was guessing why. And I thought, okay, let's get back to the root of the issue. I'm using microsoft.azure.documentdb.core. It is a client which, in the old framework, it was called microsoft.azure.documentdb, but it was not easy to ship it to the .NET Core, so they created a package called .core, which works on the core. And without core, it works on the .NET framework. But the development was quite fast, because as you can see, they started with version 0.05 preview, and after a month, they shipped the first official release. So I and the team, we started to think, okay, so maybe the gone exception is pretty much, or it might be, platform not supported exception. And that's one of the most important points, because we were facing the exceptions only from Linux and Mac OS. And we faced them on, for example, on the TeamCity, where we have parallel pipelines. On Windows, everything was good enough. So we jump into GitHub, jump into the Stack Overflow, the Google, and we find out a very funny issue, and the funny summary from our colleague. In fact, it was the issue of the Cosmos DB client. But I would like to tell you a few sentences from the summary. And we used official recommendation that we should use direct and TCP mode if you want to gain performance. And there is an official link that says we should do it, but there is no information that you shouldn't do it on Linux and Mac OS. And pretty much all microservices here on core runs Linux, right? So it is a bad recommendation for you. We also read that the Azure Cosmos DB client for .NET Core has the feature priority with the latest version of the Azure Cosmos DB .NET SDK. So if it has feature priority, but it doesn't work, in our opinion, it doesn't have the priority. And we also, at least for us, the biggest point was that it should show some exception, meaningful exception, like platform not supported exception. And I think under the hood they thought that it works, or they didn't thought that it works, but they never decided to throw platform not supported. They just shipped client which wasn't working correctly on direct mode. If you want to read the full story, it's on the GitHub, and the version 2 of the client is already patched. So if you grab the latest version of 2, it's already fixed. But I have also a good information for you. If you don't like the syntax, like creating URI, calling create document async, and then you need to specify the URI. There is an option for you, because a few days ago there was a release of version 3. Unfortunately, again or not, the NuGet package was renamed. So if you have package manager like NuGet or Packet or something else, or the .NET tool outdated, you won't notice this update. They change API a lot. However, this API is more object-oriented. There is no more creating URIs by URI factory. Everything relies on creating database and then reference to the container. And with reference to container, you can do a lot of things like creating documents, etc. So it's, at least for me, easier to use. Let's jump into another story. It's called Optimize. I'm pretty sure that on some point of your career, you had a Vanifarian story, like me. I was asked from the BA to create some application, or proof of concept application, but very, very fast, because we would like to show something to the client, and if it will be good, the client will give us a contract or something like this. And the girl said, please don't spend too much time on it. Okay, acceptable for me. But she also said, keep it clean and easy to understand, because it's pretty sure that you will not be the part of the team that will continue this project. Your job is only to create a proof of concept for the client, and later on we will assign the whole team for it. So let's create a very dummy example. Secret algorithm. Is it clean? Is it simple? Do you know what's the name of this algorithm? Fibonacci. So it is simple and it works, right? So we can ship something like this. And I'm pretty sure that after a while, you will notice the BA again saying that please make it faster because it doesn't work. So usually developers think, make it faster, okay, what kind of optimization techniques do I know? And unfortunately, sometimes even I am like a minion. Optimization, yeah. And the first answer to this kind of issues, at least usually, might be threads. If something is slow, add thread, it should be faster, should. So let's test it. I added a task.run to Fibonacci. It starts new task for each calculation of each value of the Fibonacci. So it creates a lot of tasks. And unfortunately, the performance is not that good. On the right side, you may see that it's very, very slower. I did 2 and 3, let's say, values. The first one is 15, the second one is 35. So if you see this example, you may say, okay, the threads doesn't work, so we can use less threads. So that's one of the tricks when it comes to threading. Because right now, instead of creating a task for each value, you just start 2 tasks. And later on, each task calls typical recursive function. So you did some kind of parallelism here. And for n of 15, it's slower. As you can see, for n15, it was 2 times slower. But for the big N value, it was faster. So, do you know what I have in mind? Let's find out a golden number. And after some measurement, you may say, okay, my golden number is 18. If the value is less than 18, call recursive. If it's bigger, call recursive TPL. And we are going deeper and deeper in optimization like this, because we know that we optimize the one flow, different slower, so we make trip to the different flow. But later on, you may say, okay, let's debug it. From this conference, you may learn a lot of debuggers like .trace, .purview, etc. I will use my very, very cool debugger. Maybe you also know it. And it's called console write line. And you may smile, but console write line is one of the best debuggers here, because it will give you information that Fibonacci pretty much calculates the same value, for the same entry. So we are doing few times the same job. Like, for example, value for number 3 was calculated 2 times, but the value for number 2 was calculated 3 times. So we are doing the same job several times. And then you may say, okay, if I'm doing something several times and I have the result, I can use algorithms and data structures. You may open a book, find entry called, for example, memoization. It has very nice definition, saying that it is an optimization technique primarily used to speed up computer programs by storing the results of experiencing function calls and then turning the cache to result for the same input occurred again. Sounds like a perfect solution for doing the same job several times, right? So let's change our code a little bit. Right now we are allocating some kind of storage. It might be an array, or it might be a dictionary. When it is array, you need to operate on the index and the value of the index. If you have index, you fulfill it with default values, and later on we call internal implementation. Implementation is very, very simple. Before calling Fibonacci, you check if the value is 0 or default, or if it's null. If not, you assign calculate an assigned value, and you call recursion again. And the difference is huge. You may see or not the record on the right side of you. It shows the result of memoization. It's several times faster even than the default function. It also scales, because for the bigger values, it's also very, very fast. But what have you missed? Because we played like the minions without thinking. We missed the very simple implementation of Fibonacci that uses a very simple iteration and calculates everything without recursion, without any additional storage, by just incrementing the values in different order. The iterative version is very, very fast, and it is much faster than memoization, because right now we are comparing iterative version versus memoization. So we can imagine comparison, for example, with the first version with threads. It also scales for the bigger values. So my tip from me is to do some thinking before jumping blindly to optimization, because I think we should check if the current solution still fits without jumping blindly to optimization techniques and our knowledge about performance. In the summary, I think we should always validate our performance improvement by measuring. Also, if we are not sure, it is worth to check the assembly code, because sometimes you might be surprised. Releasing product in debug mode might be funny, but it happens, even sometimes by mistake, and it is a very costly mistake. Tired compilation in .NET is quite new, and we need to get used to it. For you, the information is that if you are using advanced tools or libraries like benchmark.net, it is taking care of you for you. But if you're doing your own tricks, investigation, just remember about it. If you are not sure, just disable it for the project or for the session, or check the difference. Reading documentation sounds not funny for you, but it may save you from a lot of performance pitfalls. For example, I used documentation to get information how to use Cosmos DB, and I found out there's an overload method for HTTP client that returns the full HTTP response that I check the status code. It also doesn't buffer the whole content. ETW is very helpful. It looks like Purview is quite difficult to use, but it has quite good documentation, video tutorials. As you can see, after using Purview, we reduced allocation by 1 GB in 12 seconds application. And I think before blindly jumping to the code optimization, we should understand how it is used, who uses it, and how frequently, because it might be much better. For you, the links, I very encourage you to read Konrad and Andrei books about the books for .NET Memory Management and Andrei about benchmarking. I also added links to the documentation for Cosmos DB and its performance, like which index is good to be used. And I added stories about YAML.NET and pull request, and there is also a link to the repository from David Fowle about typical performance pitfalls in ASP.NET Core. And also one last sentence from me: if you like this kind of topics and presentation, we should encourage you to visit our conference in Warsaw, because it's all of that and full of great speakers. That's all from me. Here you have my Twitter handle and link to the presentation with the whole code repository. Thank you.